Now, there's a little bit of a problem that I'm concerned about. This Penstock pipe here is, you guys see that? 1.578 inches. Metric is down there. And this connector that I have is 1.5 inches. It's about 100 thousandths difference. This is a little bit of a slip fit, I guess. And I don't know if my pipe clamps are sufficient to clamp this. I guess there's one way to find out, huh? I'm gonna put these clamps approximately where I want them on the barbs here. So that one can go there, and that one, you guys see that? So they should both be clamping on the barb section if that's, actually no, I don't want it all the way in. There has to be clearance for the clamp. So if I pull this one almost all the way out to the edge, and then this one here, and then clamp it about there, or try to, we'll see what happens. I might need to add some heat. There we go. That should be a good watertight connection. Ooh, that's warm. Alright, and then here's the valve I intend on putting on it. So I guess we can actually just do that now, right? So there's a silicone gasket that goes on there, and then the valve mate's right on there, and then we have what's called a tri-clamp, or a sanitary clamp, to fit it in place. Of course, easier said than done. There we go. Make sure everything looks seated correctly. There we go. Except this is in the way a little bit, so I'm going to move it around to the other side. Like that. There we go. And then on the end here I have, this is a 1.5 inch sanitary fitting down to 3/4 inch national pipe taper. Not pipe thread, pipe taper. So this will be the main valve going into my turbine pit. Cool thing is, get down here for you guys to see me, and it's focusing on me, and it focuses on that, me, yeah. All of this stuff is actually pretty cheap. I know it's all fancy and stainless and looks really expensive, but it's not, because the brewing hobby, or microbrewing hobby in America, is strong. So all of these sanitary fittings are very cheap. I think this one barb fitting here with a clamp and another barb was like 15 bucks. The valve, it's an 1.5-inch valve, full port, was, well, not actually full port, it's 38 millimeters. Was, how much was it? Like 28 bucks for that. So that's a really good deal. And generally all of the fittings in this not materials, but in this standardized connection are pretty darn cheap. Before I put it in the barrel, because there's not a whole lot of room to see anything, this is the control hardware that I have. Actually, it should go this way. So the water's going to come out here and into the fitting you just saw me put in. This is an air vent. If I have to shut this valve off, it doesn't create a vacuum in the line. So this will be attached to a longer pipe that goes out to the above the water line of the barrel. This is a shutoff valve. Self-explanatory, and this is all 2-inch. My line is 1.5 inches, so this is not going to be restrictive. This is a small filter that I installed. Just coarsely, it should keep anything too big from getting into the line and clogging it inadvertently. So now I just have to glue this in. I've decided that I can get slightly better efficiency if I raise the barrel a little bit. Or more capacity, because the pipe slopes quite a bit. And there's what the controls look like up here. It's a little bit next down here from, I presume, when they pulled it off of the machine. So I'm going to cut it behind that. The best way to get these sort of fittings onto this black polyethylene pipe is to heat it up. So I brought my camp stove up here. I freaking love these little guys. If you're interested, there's a bunch of them on Amazon. I'll have links in the description. And they just take this butane fuel that comes in an aerosol can. And watch how easy this is to start. And mind you, this will run for about an hour on high or something like that. So I have to depress the lever here to engage the butane, and then I just turn it on. Ta-da! And we've got heat. So I'm going to heat up some water, pour it over the pipe, and then press the pipe onto the barb fitting. Not this one. This one's going where the two pipes join together. It'll be the one at the top of the hill that's right beside me. Alright, the water's begun to boil, so I'm going to pour it on slowly. And that should heat up the pipe quite efficiently.
Oh yeah!
Like butter. If you could call it like butter, I don't know. It's on there. Now to turn on the valve, you're loud, shut up. To turn on the valve, I'll just use this pipe here with the notch cut out, and that'll allow some water to flow down the pipe, but then I'm going to shut it off again because I still have to do the middle connection. Two-hand affair. There we go. So now water's flowing down through that pipe. And we see it draining down. Quit focusing on my arm. There we go. You can see it draining down. While the water is heating up over there, I can get the pipe ready to be connected. I was curious why it didn't seem to be draining out very quickly up there. And the reason why is, well, this end is still clamped shut. So of course it won't drain out very fast. So what I'm going to do is, this is the heavier wall pipe here. So I'm going to cut it, and I'm going to have an extra length uphill of it. And then this is the thinner wall stuff. So I just got to cut these and join them up, and then I'll have an extra thick wall piece that I can use for repairs if I ever need to. Ah! Of course there's water in it. It needs cut about here. And then here's my extra long piece. Well, you're okay over there. The inside of this is beveled to offer the least resistance. Yeah. Yeah, that's in. Whew, that was a struggle. Okay, so I walk back up here another 270 feet and I open the valve and you can hear the air gurgling there. Gurgling, that's all the water that's in the pipe, in the penstock. So at the bottom of the penstock I have that valve attached and it's closed. So the pipe's filling with water, and for that water to go somewhere, the air has to go somewhere, and the air's traveling up here, up through this pipe. Also, in technical terms, this barrel would be considered a 4-bay for the hydro system. So this is it hooked up to the big penstock, and I'm going to do a few different configurations, and we'll see what the flow looks like, how many gallons per minute it is, and how many PSI it operates at. First, I'm going to do some measurements of various nozzle combinations just to show you what's going on. The larger nozzle combinations here are never going to be used because I don't have enough water to flow large nozzles continuously. We'll start off with this little garden hose nozzle, which is, I think, about the approximate size that we're going to be using in the end. What is that, 158 thousandths? So 0.158 inches, 0.159 inches. Let me go turn on my other camera so you guys can see what this looks like. All right, camera's on. Way up there, the second stump, right there. It's my cell phone screwed to the stump with a mount. So let's turn on the valve first, the big one. See the pressure. Okay. Sorry, there's a little bit of glare and mud in the way. That's better. I still don't have this all the way down in the pit. I'm probably about 5 feet above where it would be used finally. And you can see we're almost up to 120 psi. Now if I turn this on, we'll see a small drop. Takes a little bit of time for it to stabilize. And we're barely losing any pressure, which is how it should be with such a large pipe and a small nozzle. Now I have to shut off the big valve and I'll switch nozzles. I guess we can try this while we're at it. This is just the adapter from NPT to hose thread, which for reference is 0.7 inches. And you saw there, very little pressure, but a lot of flow. This would drain my 4-bay barrel in less than a minute, I'd say. You don't notice it on the camera, but it takes a moment or two for there's a thrust generated by this. And it takes a moment after I open the valve all the way for this to start flowing full pressure, and it pushes back. Let me do that again. I'm gonna hold it with like the same force. Ah, there it goes. So that's just an interesting side effect. There's a lot of inertia of all the water in the pipe, so it takes a little bit of time for it to all get going. Now I've taken off that adapter, and it's just the 3/4 pipe. I don't know the actual diameter. It's in there, it's smaller. And there's noticeably less thrust, and it's all messed up because there's threads in here that are affecting it. Now we're gonna try it without the adapter, so this will be full 1.5 inch diameter right out of the valve. Of course I don't have any pressure, so I don't know what this is gonna do. That's a lot of water. It's all draining down the hill here. So I try not to do that very often. That'll drain my tank very fast, in seconds probably. For a quick comparison, this is my 3/4 inch pipe / garden hose that runs all the way to the top. This is what it does. There's a lot of friction in the pipe. Let me rotate the camera. So this is my smaller pipe here, and we can see that it's, come on, focus. There we go. You see the pressure is way up there at almost 120 again. You can see there's a significant pressure drop due to friction in the pipe with this running. It's all the way down to 64 psi approximately. This is the electrical gland fitting. It is approximately, because it's rubber, it's flexible, 0.555 inches. Let's see what it does. Doesn't shoot very far, does it? And then I can crank this down all the way. We'll just test it at the 2 maximum and minimum sizes. This is approximately 0.363 inches. It shoots about half as far. Let's see what the pressure is there. Maybe about 10 psi. Now I forgot to put these on the big penstock, so let me switch that back. Okay, here is the electrical gland fitting constricted to its smallest size. It's quite splashy, it's not a smooth orifice. And then I'll open up to non-restricted. Oh yeah, there it goes. Shooting twice as far as the other hose. Now I have a 6-gallon bucket. I'm going to try filling up with different nozzle combinations, see how long it takes. That'll give us a flow rate. And if we have a flow rate and a pressure, we can calculate the approximate power that's available from the nozzle. Now, flow rates above around 30 gallons per minute are unusable for this situation because that's the limit of my supply. But right now it's only about half a gallon per minute maybe. So 1/60th of my maximum flow. So I hope that this testing doesn't drain my 4-bay barrel. We'll see. Now, I'm going to open up the valve, let it generate full steady state pressure, and then I'll try putting in the barrel. Hopefully it's not going to blow the barrel away or get the camera wet. We'll see. It's only half full. It was all bubbles. We'll say that's 2.5 gallons in whatever time that was. It's a lot of splash out. We'll try the same test with it constricted. This is a 3/4 inch electrical gland fitting. Alright, that's like 3/5 full. Again, with a lot of splash out, so that'll be fun to calculate. Yay me later. I guess we'll do the full flow 1.5 inch next. Got that off so I can open this up. Alright, 1.5 inch. full. Almost full, you know, whatever. Very fast. Okay, now we'll try the hose thread adapter. Again, about 3/5 full. All right, final test. We have the garden hose nozzle, and it's open. And full. Now I'm concerned that my penstock might be empty or half empty. The pressure seemed kind of low. Either my pressure gauge is broken, which it could be, it's taken a lot of falls now, or my penstock here is actually about half empty. And the barrel's empty too, so. Okay, end of that last test, I was shutting the valve off a little bit fast, and I may have inadvertently caused a problem. So when I did this coupling, it was not here. This coupling was up here. So it seems like the pipe is pulled down, the penstock is pulled down about 3 or 4 feet, so that's probably dislodged something at the top. So I may need to address that somehow. Yeah, so with that little bit of information, I think I'm going to have to end the video here. I was going to do some more actual testing off screen to fill up this bucket without any splash out to get some real numbers. And I looked at my spreadsheet there, and it seems like a 5/16 hole will be the maximum jet size that I would be using, so that's about that size. And we can compare that to this garden hose nozzle here, and see it's a little bit bigger, quite a bit bigger, about twice the size. I was wrong, so this would be about 300 watts of capacity, and this is going to be full capacity at around 1,000 watts. So, I don't know. I guess the next video I'm going to go up the hill and address whatever's going on with the penstock, why it's disconnected. You can see the pressure here. It's been like this for at least an hour. It's not building any pressure, so it's not filling up. That's not good. So I guess we'll catch you in the next video. A little bit of a teaser under there for maybe the next video or 2 videos from now, we'll see. And then this pipe here has a drop of about 28 to 32 inches, if you catch my drift. And so that's the end of this video. I wish I had more, but clearly we have some sort of issue at the top of the hill. Last video I queried you guys about mentioning all of my Patreon supporters. I guess I can just say thanks, Patreon supporters, and that's sufficient. And if you like this video, you know, you can support me multiple different ways. Obviously Patreon, PayPal, Amazon, you know, all sorts of links in the bottom there. And what else can I say? Sun's bright. Like, comment, subscribe. See you around.